Yeah, this is going to be a little different than most of the presentations we've done because this is going to be about bands. And from what I know about the AV business, I'm going to guess that almost everybody that's in this business started out in a band or works with a band or something, because an awful lot of it goes there. So, all right, so let's get started. Um, 1969, and the Beatles are using in-ear monitors. Well, maybe not, but there's no stage monitor. There's no monitors at all. Like, hello, you're playing a stadium and you've got no monitors. Must have been a pile of fun. Um, okay, so I'm going to talk mostly about in-ear monitors because I think everybody pretty well understands why you need a microphone and that you actually do and how they work and you sing into it and that's what you need. But in-ears is still everybody's not there yet. Um, but there's such big advantages to using in-ear monitors. And so there's a challenge when we need to use wireless microphones and in-ear monitors at the same time, because the more radios we use, the harder it gets to do it. So whether they're in-ears, whether they're microphones, whether they're wireless guitar or wireless saxophone, the more radios we have in that room, in that space, the more difficult the job is. So we just have to work a little harder. With wedges, of course, you got big boxes that you got to move around and take in and out of the truck, and you got to align them, you got to set them for feedback, you got to equalize them to every venue you go to. Um, it's an awful lot of work. There's one big advantage that they're almost completely dropout free. I mean, unless you cut a cable, they're not going to stop. And of course, that's something that we need to manage with our wireless systems because we don't want it to stop. And it's certainly doable. I mean, it's not it you just do the right things and it's not a problem. But when you're using in-ears, you can pack up your whole in-ear system, in a tackle box. I mean, it doesn't take any space. You don't get any feedback unless the drummer opens his mouth, maybe. But you can get a click track. You can have other things from a director or something. You can have cues. You can have a stereo mix if you want. You're more able to hear and track pitch accurately. Um, and it's just so much easier. You don't have to scream to be heard. So you're reducing your vocal fatigue. And the biggest thing is once you get this all set up, your sound can be nearly exactly the same no matter where you go. So your sound check is like, 2 minutes. I mean, um, you don't have to deal with acoustics, right? So you're just dealing with earbuds, and so there's no sound on the stage, and also then there's no sound, muddy sound for your audience, particularly like in a church or something. If there's a lot, the more sound there is on stage, the more difficult it is for the sound man to get a good mix because he has to deal with stuff that was already there. I mean, I can remember one time I did, I was years ago, Ozfest, mixing one of the bands, and the guy had three double Marshall stacks. We were doing front of house at 120 feet away. Usually we do it at 100, but these guys were really loud. This guy had three Marshall stacks cranking, and I didn't even have him on in the PA, and he was too loud for the band. And I had 200,000 watts of a PA system. I mean, he was just that loud. So, being able to turn down is going to make the mix a whole lot better. This is just so much easier once you get used to it. Now, a lot of people have a learning curve. They're not used to hearing it this way, and they may shut it off and say, "I never want to do that again." But if you spend a little time and get this dialed in, and get some rehearsals and get used to it, the clarity is just so much better. Anyway, all right. The other thing that I'm seeing a lot of these days, are these flight racks. And so I still play in a band, and I have a rack that looks very much like this. Um, and because now with these little digital mixers, I personally myself, I use a little Midas one, which is shown there on the left, a single rack mount. I got 32 channels of hot and cold running everything. I have multi-track recording. I have just, we used to have to carry in, 3, 4 foot racks full of outboard gear to match what's all in that box. So I have all of that in one rack space, right? And so you can make these things small. If you fly, you can put them in these new lightweight racks, and you can, they go in Pelican cases, and they don't go oversized or overweight. So it's really a great way to set up your band. You mix with an iPad. And everybody in my band, everybody has their own iPad on stage. They got their own monitor mix. They can do whatever they want anytime they want. It's a piece of cake. All right, so here's the sales pitch. We have a couple of new products. We have a Distro 5 HDR, which is a antenna distribution system, much like our Distro 4 that you might know, or our Distro 9 HDR. This is actually the smaller version of a Distro 9 HDR. This will allow you to connect up to 5 receivers in a half rack space. Likewise, we have a new combiner, the Combine 6 HDR, and this will let you have 6 sets of in-ear monitors, 6 different transmitters, 6 different carriers, right? So for an awful lot of bands, this would be your entire system. You don't need, 2 or 3 rack spaces to do this up anymore. You can do this all in one rack space. I should say the HDR system, this is just the best stuff you can buy. This is our racing team models. And nobody ever complained about having the best. I mean, this is going to give you the least interference. It's going to give you the most channels wherever you go. That may be 2 more channels, or maybe 200 more channels. It just depends where you are. But now you can get all that equipment in one rack space. So, okay, end of commercial. So, so we gotta make all this stuff together. I'm back to, this is the thing that I always preach. This is what has to happen with wireless microphones and wireless ears. If I say mics and I say ears, they're the same thing. They're radios. Okay. What you have to do is you have to get the signal from your transmitter through the air into the antenna, down the wire, into the distribution system, into your receivers or whatever. And you need to have a signal that is 20 dB stronger than whatever the noise floor is wherever you are. And of course that's tougher in metro areas. That's tough in Times Square. And it's probably a whole lot easier on top of a mountain, in Idaho somewhere. But this has to happen. Normally, you're probably well above that. You might be 40 dB above that. And then somebody puts their hand over an antenna, or, hides it or sticks it in their pocket, or, there's all kinds of things that happen. So it's moving. This is a very dynamic dance, but you have to maintain this minimum. When you do, your radios lock. Your transmitters and your receivers lock together, and they disregard everything else. If it drops very much below that, they start picking up every radio station in the world, and they have to try to figure out which one they want. So this is the goal for both microphones, in-ears, guitar wireless, every kind of radio, FM radio. This is what you need to achieve. So we have to find spots. Obviously, there's TV stations are a big problem because they're 500 kilowatt transmitters, and you're dealing with 10 milliwatts, so they can wipe you out 150 miles away from you. So we need to find empty spots between the TV stations. We have to look out for interference from LED stage lighting. You see the yellow down at the bottom, and low band 5G cell phone, T-Mobile cell phone service. So when you have an audience and they've got cell phones in their pockets, They are putting more radios in that room along with the radios that you already have, right? So that's what's happening. So all of a sudden you just have lots and lots and lots of radios. Now they're a little bit out of your frequency, but they're close enough that they mix with your microphones and they raise this noise floor. So you got to get above the dark orange line on the top roughly represents where 20 dB would be at any particular frequency. Remember, this is always frequency dependent. Okay, so the first thing we want to do to help maintain that 20 dB is try to eliminate as many antennas as we can, right? Because the antennas, they mix and they interfere with each other. They become, when a radio signal is going through an antenna, it becomes an electromagnet. And that magnetic field, when there's another antenna, closer than a few wavelengths, which is roughly about 6 feet, it jumps from one antenna into the other where it becomes noise. So it's adding the noise. And also, if you have something that looks like this, there's no telling where it's actually going. When you put antennas together, they create arrays. So like when we put speakers together a certain way, we create line arrays. That's what happens with antennas. And that's how we design other antennas. We put multiple antennas together in the same package, but it's very, there's a lot of math. So it's exactly the right way to do it. If you just haphazardly do it like this, what you end up with is hot and cold spots on your stage. So you might be working for an hour and then your singer steps, 5 feet into the wrong spot on the stage, and it could be a tiny spot. And all of a sudden he's got nothing. It just drops out because you don't have even coverage across the stage. The other thing I would talk about is with in-ears. Almost all of them are non-diversity, right? So with your wireless mics, you have two antennas, and the hope is that if one antenna goes bad, the other one doesn't go bad at the same time. And that works very well. It's not foolproof. It does still drop out, but it works really well. You don't have that with in-ears. Almost all in-ears are analog, and they're single-ended radios. Just because, you got a belt pack. If I had to build a second receiver in there, that your wireless mics have two receivers in each one of those boxes, right? At least two receivers. Some have more. But your belt pack, there's no room. It would get heavy, it would get big, and the batteries wouldn't last very long. So they're single channel radios. And that means depending on how you move, as you twist and bend, the ability for the receiver on your belt pack, the antenna on your belt pack, to find the signal from the transmitter is constantly changing. That's called polarization fades. And we'll talk about that in a little bit farther in. I also want to point out, this is probably the very worst thing that you could do, is that you have wireless microphone antennas, which are receiving radio waves. And then you have in-ear monitor antennas in the green there, which are transmitting. So when you do this, your IEMs are screaming lots and lots of power directly into those antennas. I mean, they're inches away. So you're maybe overloading those radios. This is not a good system. Now, I guess for these people, it worked. And, that's always, that's kind of the funny thing. If it works, it works. If it works, it works. But there are best practices. There's the way to do, there are ways that you can do it that will always give you the best result. Because you don't want your toes right up to the edge of the cliff, because one more thing happens and you lose signal. So you want to be 10 or 20 or 100 feet back from the end of the cliff. You may not need it, but count on it. If you're using wireless in a band right now, stuff happens. And so you need all the extra dynamic range that you can possibly get. So this is an absolute no-no. If you have a rack that looks like this, you need a distro or you need a combiner, preferably both actually, and you need to move the wireless mic antennas at least 6 feet away from the in-ear monitor antennas, and you don't want to point them at it, right? So think about it. Think about it the same way you think about a microphone and feedback, right? You definitely don't want to point your microphone at the speaker. Turn it around backwards, and you get a lot more level before it's going to feed back. So the same thing happens with these antennas. These are transducers. Just, consider they were speakers and microphones. They don't get feedback, but the same kind of problem happens. Okay. So another thing that happens when you have lots of radios together, actually, when you have two, and the more you have, the worse this gets, is they interact with each other and create intermodulation distortion. And the problem with that is that you can see as these get close together, you can see the other spikes go up. That means you can't tune to those frequencies, or you can't tune very close to those frequencies. So you could have a situation where you think you've got everything set up, and all of a sudden, your two lead singers get arm in arm and their microphones are very close together, and all of a sudden they start generating enough intermod that it knocks somebody else off the air, knocks your ears off the air, knocks your mics off the air. It doesn't care. Again, these are all radios. They don't care which way they're going. So we need to avoid this intermod, and that's why we use distros and combiners, right? It's a much better way of coupling all this stuff up. So one of the ways that we can lower intermodulation is to use lower power. Now this seems backwards, but you never want to use any more power than you actually need. So you need to walk test your system. If you're going to be 50 feet away from the stage, or 150 or 300 feet or 20 feet, whatever it is, you need to make sure that you work there. And then you want to begin to turn down things. We don't want any power that we don't need. So you can see kind of down at the bottom of that, you can see that the lower power one is 10 dB lower than the higher power one. And that means that the intermodulation is 1/1000th of what it is, which is kind of hard to tell from those jaggedy spikes, but it is, because every time you turn down the power by 1 dB, you turn down the intermodulation by 3 dB. So if we're looking at that red one there, there's a whole lot of spots where we couldn't tune our microphones or our ears to, because they're being used up by these sidebands, by these phantom radio stations. They're real, you can measure them, they're just garbage. So all of a sudden it's like you have 100 more radios on your stage, and then every time you generate one, it becomes a radio and it generates more. So this builds up really quickly. So for every 1 dB of power that we can turn down, our transmit powers, we'll reduce our intermod by 3 dB. So in that case, we turned it down by 10 dB. That means we turned the intermod down by 30 dB, 1,000 to 1, right? So how do we do that? Or why do we do that? Let's talk about this. If we turn it down and we use an antenna that has gain, right? So this is our CP beam antenna. This is one of the best possible antennas you could ever use for your in-ear monitors, but it has 10 dB of gain. So if you had like Shure PSM 900s, which could actually transmit at 100 milliwatts of power, you actually need a license to use more than 50, but that's a different story. So if it had 100 milliwatts of power, and you were just shoving that into the whip antenna that it came with, you'd essentially have that much power out in the air. If you turn down your transmitter to 10 milliwatts, so it's now 1/10 of the power that it was, and you're going, wow, that's going to be really weak. The antenna has 10 dB of boost. So you end up in the same place, but you end up with 30 dB lower of intermodulation, which means you can find channels, you won't get knocked off the air nearly as much. All that stuff is taken care of by this. So you don't need high power unless you have people on the other side of a football field. Generally 10 milliwatt, if you're on a stage, if you're on a 40, 50, 60, 80, 100-foot stage, 10 milliwatts will get that all day long. I mean, you just don't need the bigger power. Yeah, I know when you bought your PA system, you bought 1,000-watt amplifier, and even though you're running it at 100 watts and you got 900 watts left over, you call that headroom. That's a good thing there, but it's not with radios. If I only need, 100 watts and I'm 101 watt, I'm going backwards. I don't want it any bigger. So we want to keep these at very low power as we can. Um, so with in-ears, you go into the screen, and somewhere in there it's different for each brand, but you're going to find an RF power setting. And what you're going to do is actually turn down the power of your transmitters. So if you're using that CP beam, I definitely recommend running at 10 milliwatts unless you're trying to get somebody 300, 400 feet away. If they're less than 100 feet away, less than 200 feet probably. I can tell you in my own personal system that I use with my own personal band, I'm running 10 milliwatts, and we have a room that we rehearse in. That's a separate building, and I have left the monitors on, walked back to the house, which is 200 feet away. Now through 3 walls and 200 feet, I'm still connected with 10 milliwatts. So you don't need any more power than that. You really don't. You do have to test it. I mean, one time out of 100,000, I'm going to be wrong, but I got a long way to go before that's going to hit me. So you want to turn this down. It just, like I said, it's going to give you more channels to tune to. It's going to give you less interference. So if we have to work with mics and ears together, the strategy is to try to separate them. Put all the mics at one end of the band and all the ears at the other end of the band. I don't care which one particularly is at the top and which one is at the bottom. What I care about is the separation. So here's an actual scan, and all the microphones could be tuned in the top picture across 5 megahertz. Now, when I say all the microphones, all the wireless, don't forget, if your guitar player's got a wireless or your sax player's got a wireless, that's a radio too. You got to count those. If you leave a radio out, the whole thing goes away. It doesn't hold anymore. But in this particular case, we were able to tune all the microphones from 5 megahertz wide. Now, if you've got one mic that sticks out of that, it becomes the width of that whole thing, not the majority of the cluster. You got to look at the entirety of the cluster. Okay, same way, we got all the ears, there happen to be 16 ears in this case, and we got them tuned into 15 megahertz. What happens, so you can see the width, the 5 megahertz and the 15 megahertz. What happens is your primary interference is going to be that same width above and below that block that you've tuned out. So in this case, I've got 5 megahertz for my mic. I'm adding 5 more to the top of that. 15 for my ears. I'm adding 15 to the bottom of that. And look, I have a nice big space in between them. That's the goal. The better you can do that, the easier it's going to be. Now, you don't absolutely have to do that, but it's going to be a rough day if you don't, right? So again, you can see if I had to open those up, if I had to tune the mics to 10 megahertz and the ears to 25, I still have a gap, but it's getting close. And if I have to tune them even wider, you see by the time I've done this, they're overlapping. And this will make it hard to make stuff work. So if you're buying new, or you've already got mics for your band, and you're going to buy ears, you want to get them, you want to pick blocks that will allow you to tune as far away from the other that you've already got as possible. So this is a strategy. You can't always do this, but this is what you'd like to do if you possibly can. I want to talk about, I said I'd talk about polarization. Um, so let's see, let's look at it here. So again, with in-ear monitors, we have almost all of them have only one antenna. PSM 1000s have two, but just about everything else in the world that I know of only has a single antenna. And so you want to use a circular polarized antenna with that. Here's why. So if when you use a paddle or a whip, the radio signal that comes out of that is a wave that's in a line. If we turned that sideways, we'd just be looking at a straight line, right? Um, and it goes straight into your antenna. So if your transmitting antenna is vertical, like the top picture, and your belt pack is vertical, you have no problem. Your belt pack will pick up all the signal, less the distance that it's supposed to do. A circular polarized antenna is spinning the transmission in 360 degrees. So it's a circle. So it doesn't matter how your receiver is, right? Because if I start turning sideways, if I move a little bit, um, I'm going to lose some signal from my transmitter with conventional antennas, with whips or paddles, right? If we can nail everything down, whips and paddles work fine. But that's why you're wearing, portable, is so you can move, so you can bend and twist and crowd surf and whatever people do, you can do that. If you manage to get all the way horizontal and your transmitting antenna was vertical in the top example there, you would lose over 20 dB of signal. You're dead. That means you're now picking up, if you get to this position, that means you're picking up less than 1% of the signal that's being transmitted compared to when it was vertical. You've gone from 100% to 1%. So what happens is, so the other thing about in-ear monitors, they're almost all analog. And there's a very good reason for that if you're a singer and you had a digital wireless, you add some additional latency and you get a problem that the singer's going to hear themselves through the bone conduction, from their jaw. They have a bone, so they're straight wired straight into their ear. And the electronics, because they're digital, are going to be a little tiny bit latency. And so you mix those two signals together, and because they're out of time with each other, you get what's called comb filtering. It'll sound like you're singing through a cardboard tube, and that's not fun. So it's not a problem for the guitar player, but it is for the singer. So we use analog because there's no latency with analog. Well, the speed of light, we'll call that none. That's pretty fast. So the problem with analog in-ears is the quality of sound that you hear is very much related to the signal strength. So even if you don't lay flat on your back like this, as you bend and twist, because your ability to pick up the signal is going up and down, the sound quality is going to follow that. So you start getting, you get little noises, you get birdies, you get junk, you lose fidelity, you get distortion. Well, it's not huge, but it's certainly not what you want. With this circular polarized antenna, it doesn't matter how you move, right? So no matter what you do, bend, twist, lay, stand, stack, anything, your signal stays constant. It's always between 0 and -3. It can't get worse than that. It stays closer to the 0 side, but you could lose 3 dB of signal. So it's not perfect, but it's just not shifting your signal. So your sound quality, and if you're the guy listening to this, that's pretty darn important, right? So so that's why you want to use a circular polarized antenna. And actually, out of everything that we're talking about, if you've already got a system and you're fine with using multiple rack spaces and you're good with medium quality stuff, and plenty of people are. So I'm not saying that you have to change that, but the biggest improvement you could make to that system would be to get a circular polarized antenna like our CP beam here. That's going to make a huge difference to the quality of your in-ear monitor system. So there's another thing that has to happen. You have to get all your frequencies together. So you need a frequency coordination program. And what this does, this picks out your channels. This is going to tell you the best frequencies you can use at your venue. But what this is actually doing is this is assigning all that intermodulation to frequencies where it isn't going to bother us. It's still going to be there, but we're going to move it to frequencies that probably don't, as best we can, that don't interfere with the things that we want, right? So it takes a lot of math to do that. There's a lot of programs. Here's one that you should look at. So if you go to our website, rfvenue.com, there's a button at the top in the toolbar that says Performance Tools that will take you to this. Now, the cool thing about this is you can do this from your phone. So when you get to a gig, you don't have to have a computer. You can do it from anything. It's a web app. You don't sign up, you don't download, you just use it. So it's going to start you off. It takes you to this screen, and you're going to enter your address. That's just put in your address, and then it's going to get started. On the next page, you're going to tell it your inventory. So you got to tell it your mics, you got to tell it your ears, you got to tell it your guitar wirelesses. You just go to these drop down boxes and tell it how many you got and hit add. So you enter your inventory, and then it's going to come back with a coordination based on your geography and what it knows about all the radios around you. And so I don't have enough room on this, but it's going to give you individual frequencies for each of your mics and each of your ears that you can tune it to. You see it moves them all into the spots. The big red blocks are television channels. You can't operate there. I mean, it's not legal, and you can't do it anyway. So you have to know where these holes are. So if you get on the tour bus, you need to do this every time you set up. If you play the same, if it's at a church and you're not moving the building, you don't have to check this as frequently. Although things do change, so don't count on one setup lasting for years. Right now, the FCC is reallocating television repeaters, and I'm getting lots of phone. They started doing that in June, and so all of a sudden, these are little mini TV stations that rebroadcast, especially in hilly areas and stuff, because TV doesn't drop down into the valleys, so they put these little repeaters down in the valleys. Anyway, this is very simple. You can do this in about 2 minutes. Just tell it where you are and tell it what you've got, and you'll get this. Now, you can improve on this. That's another topic. There's a button here that says Upload Scan. If you have a scanner, and we make a really neat one called the Spectrum Recorder, it will actually scan and you'll get a better picture. What this program doesn't know, if you don't scan, it doesn't know exactly what's there. So if you happen to have an X-ray machine on your stage, it's going to generate a bunch of junk, and this program isn't going to know about it. I haven't seen many X-ray machines on stages, but it could happen. So there could be things in your building that are particularly difficult. So when you upload a scan, if you get a scanner and you upload that scan, this is going to get you. Without the scanner, this is going to get you way, way, way up there. I don't know, picking numbers out of the air. 95% of the way there, 90%, 95% of the way. If you put a scan in, you're going to be 99% of the way there. So, when failure is not an option, that's what you do. You got to get the best you can get. But you can get awfully close using this free program that take you like a minute and a half to learn. So you want to do this. You can start doing this. You don't have to have mics and ears. It could be mics only. It could be ears only. You might just have a guitar wireless on your stage and no other wireless. You still can use this program. So I would suggest, go to our website, take a look at this, bookmark it, and then, you know, you've got this built in. Because there's two parts to making a radio work, right? At our venue, we can take care of the part of getting the radio wave from point A to point B, right? That's what we do. But when you get it there, the other half that we have no control over is what's there when you get there. You have to find an open space to tune to, right? And this program is going to show you this. So, you know, it's going to show you, like I said, you're going to have to tune in the black. You see those lines. The orange lines happen to be the ears and the blue lines happen to be the mics, but they are the specific frequencies they are so as to minimize that intermodulation. It's still, the intermod's going to happen, but we want to be able to move it to frequencies that don't bother us or don't bother us as much. You're not going to eliminate it, so we're just trying to make this as good as we can. So this is a very important part of this whole thing. So okay, back to the commercial. If you want the best there is out there, this is it. You put this in your rack, and this is as good as you're going to get. A diversity fin for the wireless mics is going to outperform a pair of paddles. It's going to outperform a pair of whips. And a CP beam circular polarized antenna is going to outperform any other non-circular polarized antennas. And then these two just simply are the best electronics you can get if you can work within 5 mics and 6 ears. Now you can expand these too. So if you had 10 mics and 12 ears, you could put 2 of these together. So, you know, if you have a really big band, you can do that. You're not painted into a corner. But for most people, this probably is a pretty good combination. And again, I just want to say this works with all brands. We don't care. Radio waves don't have a brand. They're a universal force of nature. So what goes on inside the radio, yeah, that's proprietary, and you know you can't use an Audio-Technica transmitter with a Sennheiser receiver. But you can use RF venue antenna products with any of these brands, you know, as long as they're in the right frequency range. And if you're in North America, if you're in the United States, it's nearly impossible to screw this up because everything is so regulated by the FCC. And it is around most places in the world. So you don't have to worry about it. It works with all brands, works with analog, works with digital. So I think with that, Mr. Adam, I probably talked too long, but I hope that helps you out, because there ain't nothing worse than getting ready to start playing and your gear doesn't work, right? You got problems. That just drives me crazy. So there you go.
That was awesome, Don. It's definitely different from what we usually do, and I think a lot of people probably appreciated your approach there. So that was, even me, I'm always learning. So thank you.
You know what I didn't think what would have been a good question for you to ask, to poll questions. How many people are in a band or were in a band? Because I'm curious to know out of all these people. I'm going to guess almost everybody here is, because almost everybody in the AV business, you know, you played in a band in college or high school, or you still do. I'm an old guy. I still play in a band because I have more fun doing that. You know, I've been in national acts. I've been in, you know, corner beer bar bands. I've done everything. I play because I love playing, and I still do. Okay, sorry.
Well, I didn't set up that poll, but if anyone's not familiar with being in a band or working with a band, just shoot us a message in chat.
Yeah, so if you've never seen a band before. Yeah.
But without further ado, we've got some good questions you guys submitted, and Richard answered some really good questions coming in. So certainly if you have any more questions right now, you can enter them into the questions and answers and we'll get to them. Dawn, antenna placement when using both wireless mics and in-ears.
So, well, I think I covered that. There's a very important thing that you could do wrong, that you definitely don't want to do, and that's that you don't want to point the wireless mic antennas at the in-ear monitor antennas. You don't want to point them at each other. So the worst thing you could do would be to put your wireless mic antennas, let's say, on one side of the stage and your in-ear monitor transmitting antenna on the other side of the stage, and point them at each other, right? So the preferable thing to do would be to have them both on the same wall. They can both be in the wing of the stage. They both can be in the back of the hall pointed towards the stage. that's fine. They do need to be separated probably by at least 6 feet. 6 to 10 feet would be a good distance to separate those antennas. So again, if you're using two paddles, then you got to be 6 foot from the paddle to the in-ear monitor and then 6 feet to the other paddle. Use a diversity fin. You only got to do it that once, so that saves you some time and setup. But that's the thing. You don't want to point them at each other. You got a pitcher and a catcher. Um, they don't want to. They don't want to both be the same.
Plus, if you can put your transmits in front of the receives, that's if you don't have a lot of space, at least put the
Yeah,
trans put the receives behind.
yeah, right. Because then it's going forward. It's not going
Yeah.
backwards as much.
Yeah.
It's going
Yes.
backwards a little. So if you have that ability, you can pick up an extra point or two by doing that. Thank you, Richard.
Mhm.
Very cool. Good tips, guys. Next one. Why should we not use Dante-enabled mic receivers? Is this Dante-enabled receiver a replacement for traditional RF antennas?
As far as I know, Dante is just for audio. It doesn't do radio waves. So your Dante connected gear um, allows, everything to be self-aware of everything else. And there's all kinds of software that does that. But I don't, unless there's something brand new, Dante does not do radio waves, right? So that's outside of what Dante does.
Yeah, a lot of installers prefer to run the receivers far and have a shorter antenna cable to the receiver, so that Dante allows you to do that, run the
Right.
audio and power much farther away than you normally would. Okay, so what situations will bandpass filters help fix?
Well, okay, so bandpass filters you can use on your wireless microphones, right? Not on your in-ears. Well, not easily on your in-ears. If you're sending a rocket to the moon, then you can use them on your in-ears. But no, they're just for your wireless mics. So if we go back to that strategy where I've got the mics at one end of the band and the ears at the other end of the band, I could use the bandpass filters to protect the wireless microphones from even seeing the in-ear monitors, removing one other potential source of interference, which is creating a lot of intermod. So it would cut down the intermod. And of course, just using the bandpass filters, the biggest thing the bandpass filters do in the United States is they block out T-Mobile. And that's your whole audience has cell phones in their pockets. So that can get to be a lot of extra noise. A bandpass filter is probably gonna lower your noise floor by 4 to 6 dB. I've seen it be more than 15 dB, but that's kind of like winning the lottery. That's not going to happen very much, but it's going to improve your noise floor 4 to 6 dB. And remember, you got to get 20. So picking up an extra 4 to 6 is huge. So again, it's just moving your toes farther away from the edge of the cliff, make it much more comfortable that you're going to get through the night without having any dropouts. It's highly recommended.
Excellent, excellent. And we had this one question already, which Richard fielded in the questions and answers. Multi-zone antenna setup for IEMs.
Well, if it's fairly simple, you can just split the output of your combiner, right? So you'd have the combiner, it would normally go to the transmitting antenna. If you just need a second antenna, you can use a passive splitter, and now you can use two antennas if you need to cover two different rooms, two different areas. You can continue to do that, but you got to remember when you split your antennas in half, you're now sending half the power to each antenna. Plus, there's a little loss for the splitter. So you've cut down your power by half. So if you're going to do this for four, now each one of them only has a quarter of the power that the others did. And you begin to, as we add more and more electronics, it's always hard to say how many of anything you can do, because when you add electronics, you're adding to the noise floor. You're always adding distortion and noise. Nobody's electronics are perfect. So you're always adding a little bit. And remember, we have to maintain that 20 dB of signal to noise floor. We're raising the noise floor. So there gets to be a point where that wouldn't work. So if, for example, if I wanted to split it to four antennas, Um, that's not going to work in Times Square, but it's going to work out in the middle of nowhere somewhere, maybe. You always have to take that into account. But if you just need two, you can simply get one of our passive splitters, our 2x1 splits, take the output, and that way you could do you could have antennas in two separate rooms, and then you'd still be connected room to room.
One thing on that too is if you are curious about splitting it passively and you think you have two zones, you need to make sure that the zones don't blend into each other, because then you'll degrade your system. If the two antennas are competing, you'll have like pretty much a competition between the two. So basically walk it first to make sure that when you go in the other room and your level is pretty low, then you know for sure. And
Yeah,
if you
go ahead.
I was gonna say you could, and if you're at the edge of that, you can attenuate by putting a passive attenuation on that side of it. So there's a little bit of investigation you need to do sometimes just to determine if I need two zones at all.
Yeah, so
Right.
so imagine yourself imagine there's two rooms. There's a west room and an east room, and there's a wall dividing them, and there's a doorway that connects the two. Imagine yourself standing in the doorway and trying to listen to people in two rooms talk to you at the same time.
Oh, you're giving me a headache
That's
now. I can't think
Yeah,
about
that's
that.
what's happening. So it's easy to listen to one and then I can turn and listen to the other. But if I've got, trying to understand what two people are saying at the same time is very difficult. It's not impossible, but you're making it hard. So that's why you never want more antennas, right? You just want to pick up the signal once, if possible.
Very good. But this last question here, we could
Right.
probably have a whole webinar on this question. Further explain decibel gain on antennas.
Oh, okay. So antennas, yeah, this is a little like, huh? So antennas have what we call passive gain, right? They don't have amplifiers. They have passive gain. And so if you can imagine, we take what's called an isotropic antenna, which is a model which can't exist in the world. But imagine that you had an antenna and it was a single point. It would emanate in a hemisphere, all up, down, sideways, all directions at once. So you put X amount of power, right? You have, let's say you have a unit of 1 power going into that dot antenna in the middle of your hemisphere, right? If I cut that hemisphere in half, if I make it so the antenna doesn't go into the bottom half, but shoots all its energy into the top half, I have a gain of 2. I have the same amount of power coming out of the antenna, but I've focused it into a more limited space. And so as you begin to crowd these spaces down, the power is getting more and more concentrated. So think of it's amplification in the way that a megaphone would amplify if you put it up to your mouth. It doesn't make your mouth any louder. It just controls it. It just sends all the energy into a more narrow space. So we count that as gain. So you have much more pickup in a certain area and much less pickup in another area. Because really, you only want to pick up where your microphone's actually going to be, right? Because everything else that you're picking up the noise that's sitting there. So, if you're on a stage, you just want to pick up the stage. You don't want to pick up the audience, right? So we start using directional antennas, and then we can count that gain because it's going to boost up the signal. Remember, we're going back to that 20 dB thing. So again, if my example of a whole sphere and a hemisphere, I just picked up, well, I didn't count it in dB, but I just picked up more gain on that other side by using a hemispherical antenna instead of a spherical antenna, if you just conceptually anyway. So I've raised my signal without raising my noise.
Can I add something real quick too, Don?
Mhm.
So it's important to understand that's why we have spectrum analyzers on site, because now we can plug into that antenna rig and see what the difference is too visually, and especially the noise floor. If you're creating your own noise floor by using a two-directional of an antenna, or realizing that you're there's something in the vicinity of that antenna that's giving you noise, uh, and you don't use a spectrum analyzer to really dig in deep, you're just guessing in a way. So if you want your result to be 100% tested and thought out, the spectrum analyzer is definitely one of the most important tools.
Yeah, that's a new, I mean, nobody ever, well, almost nobody ever needed that kind of stuff before. 10 years ago,
Yeah.
it was so easy to do that, like, yeah, some people did it, but like you didn't have to because you almost never could screw up. We just have so little space anymore that
Yeah.
you have to be more and more and more and more exacting every day.
Yeah.
So, so someday in the very near future, you're probably not going to be able to operate in a lot of spots without being able to measure them. If you go look on our website, we got a really cool new tool called a spectrum recorder, and Richard's got a video for that. I mean, that's going to cost you whatever they are, $700-800, but that's going to make your radios work day after day after day. So if that's important to you, um, I would highly recommend getting one now. I would say a couple of years from now, you're going to not have much luck without one. I don't know. It depends where you are. But again, and they keep getting easier and easier to use. So using a spectrum analyzer in the past, was a $10,000, $20,000 instrument that weighed 80 pounds, and you needed, 6 weeks of school to learn how to use it. This thing we got now is like plug and play, and you don't even have to push a go button. I mean, it just does it all by itself. So you just, plug it in, and it goes all by itself, and it plugs back into that spectrum analyzer program, excuse me, the frequency coordination program. So, get that in the back of your head. It's a very valuable tool. It means you're not guessing. You still can, you can guess somewhat, but it's getting harder every day. So that's
Yeah.
definitely something you want to look
Yeah.
into.
Yeah. Times have changed. You said it perfectly. We can't just guess as much, which it makes it more enjoyable. I mean, yeah, you have harder jobs ahead of you, but it's really rewarding when you really nail it.
Yeah, I mean, 10 years
Uh,
ago, you could stick a coat hanger in the back of your radio and it'd probably work.
yeah.
Not, good luck with that now. It was just that easy, and now it's not because there's so many more radios and there's so little space because we're using it all up with cell phones.
Yep.
So, that's just the way the world is. But all this stuff is getting better. The performance is enormously better. 10 years ago, wireless microphones sucked. I mean, I used to run a PA company too, and I hated when I had to have a singer use a wireless mic. It made my PA sound bad. It sounded like a bad cassette recording. But now, that's not the case. So this stuff's getting better and better and better. Um,
Very cool. Very cool. Well, thanks everyone for your time. We're coming up on the end of our session here. We really appreciate your attendance. I'm going to send you a follow-up form to see how we did. We always value your feedback. I just wanted to call out one thing that Dawn talked about during the session that's really cool that we just launched. An update to Wireless System Builder for Spectrum Recorder. So if any of you guys are using Spectrum Recorder already, there's a bulk upload feature that just changed on there. You can actually upload a zip file of scans to comb through the timestamp with System Builder. So check that out. Let us know how you like it, how it's working for you. And let us know. You can reach all of us at info@rfnu.com. We're happy to answer any questions you may have about our products, techniques, RF in general, whatever you got, topics for another webinar, just hit us up anytime. So without further ado, thank you guys, and we really appreciate your time, and we'll see you on the next one. So
yeah, thanks, guys. I hope that helps you out.